Problem number 31. Consider the function f double prime of x equals x minus 2 quantity squared times x minus 5 quantity cubed, all of that over x minus 9 to the fifth. And our domain is going to be negative infinity to 9, union 9 to infinity. Realize we've got the treble spot there dividing by, if we're plugging in x equal to 9, we're dividing by 0 there. And this is the domain of f, and also for f prime and f double prime. Realize I'm not telling you what f is, I'm telling you what f double prime of x is. So this is already kind of cutting a couple steps forward here. I gave you the second derivative, and I'm asking you about concavity here. So for part A, we want to find where f is concave up, and then for part B is find where f is concave down. For this, we really want to be making a sign chart here. So there's 3 trouble spots, 2, 5, and 9. Right? You know, trouble spot is maybe a strong word here, but there's 3 places in which these things, something could be happening here. So x minus 9, you know, the domain doesn't include 9, so we should put that there. And then these 2 factors are 0 at 2 and at 5, respectively, because we want to think about if the we want to think about the sign of the second derivative to tell us about concavity here. Then this is why we care about this stuff. Okay, so let's start kind of checking on things here. Let me just kind of put a dashed line here, say that's not actually in the domain. And we're thinking about f double prime of x here. F double prime of x is 0 when x is equal to 2. Plug in 2, we get 0 here. It's also 0, x is equal to 5. Okay, so let's see what is going on here. So let's just plug in some test points here. So we plug in x is equal to 0 for something less than 2. We would get 0 minus 2 squared times 0 minus 5 cubed over 0 minus 9 to the fifth. And so this is going to be positive times this is negative. All of that, I should just put a minus sign, all of that over something negative here. And so those cancel out. So f double prime x is positive for x is less than 2. How about between 2 and 5? We can test like x is equal to 3 here. We would get 3 minus 2 squared times 3 minus 5 cubed over 3 minus 9 to the fifth. And so this would be 1 squared is positive, negative 2 cubed is negative, and then that's a negative sign. And then negative 6 to the fifth, that's also negative. Positive times negative over negative, this is also positive. Okay, how about x is equal to, let's pick something between 5 and 9, like 7. So we would have 7 minus 2 squared times 7 minus 5 cubed over 7 minus 9 to the fifth. So this would be something positive, and then this term would also be positive. The denominator would be negative here, so we end up with something negative. And then finally, what if x is bigger than 9, like 10? So this would be like 10 minus 2 squared times 10 minus 5 cubed over 10 minus 9 to the fifth. Everything here is positive, and so this is positive. So once we construct the sign chart, now let's go ahead and answer A and B. Where is f concave up? So concave up from negative infinity to 2, but not at 2, union from 2 to 5. And then union from 9 to infinity, and all of those are open intervals. For concave down, we're looking for when the second derivative is negative. That would be from 5 to 9. And then finally, part C says, find where does f have an inflection point. An inflection point is where the sign of the second derivative changes and our function is defined. So has an inflection point at x is equal to 5 because the sign of the second derivative changes from positive to negative at x is equal to 5. You might also think that x is equal to 9 is an inflection point, but that's not in the domain of our function, so it can't be an inflection point.